Okay, here's problem 2 of the 5 that you guys have. And again, I'm doing all of these in real time, so if I do kind of pause a little bit, that just means that I'm thinking there with you, okay? All right, here we go. So I right away noticed that there's no picture. So I might need to graph this on my calculator, okay? The polar curve R is given by 3 theta plus sine theta. Okay, so right away, I'm going to go ahead and make sure that I go to mode and I switch to polar, okay, so that I can get a picture at least. So right now, I'm actually typing 3 theta plus sine theta for the first R there in the Y1 section. I'm going to go ahead and make sure that my window goes from 0 to 2 pi. It looks like it's going from 0 to 6.283, which is 2 pi. So that's enough for me to go ahead and hit graph, okay? So it's looking like something like this. If I had to just, if I had to just quickly sketch it, it would look a little bit like that, okay? But that's just to give you a visual, okay? So it says find the area in the second quadrant. So that means pretty much everything just here. Okay? By the coordinate axes and the graph of R. So that tells you a lot actually, because that tells you where you're starting and where you're stopping. So here we go, part A. You know it's going to be 1/2 the integral of your radius. Now I might use the y1 function here, but you really don't have to. So 1/2 r squared. Think about where the bounds should be. Press play when you're ready. Knowing that it's in the second quadrant, that means you're starting at pi over 2 and you're traveling all the way over to pi. That's it. You plug and chug. Okay. Well, actually, they do ask you to find the... Wait, never mind. I thought they were asking you to find the graph of it. But they're telling you to find the area of it. Let's double check. Let's take a look. Yeah, that looks good. Okay, you plug and chug there, you get an answer. Here's part B. So from pi over 2 to pi, there's one point on the polar curve where the x-coordinate is -3. So somewhere here. Find the angle that corresponds to point P. So we're trying to find this angle here. Okay, so find the y-coordinate of that point and find the angle of that point. Okay, so I know that x is equal to r cosine theta, right? And I also know that y is equal to r sine theta. Okay, so if x is -3 and r is 3 theta plus sine theta, cosine theta, we could actually find out what that angle is. Now here, since this is a calculator question, use your calculator to speed things up here, okay? I'm going to tell you guys exactly what I would do. Since I'm calculating, I want to go ahead and go back to my function mode, okay? And what I'm going to do here is, once I go back to function, go back to y equals, make sure that everything is clear. I'm going to graph -3 as y1, and all of this as y2. So y2 will be the quantity of 3 theta plus sine theta, or in this case x, times cosine x. Okay, I'm going to go ahead and go to window, and I'm going to change it from x min to pi over 2, and x max to be pi, because I know the intersection is going to be somewhere in between. And hopefully we'll see an intersection here. We do. Okay, so I mean, if you want to just get an image of what I have on my calculator, I have something that kind of looks like something that kind of looks like that. Okay, but notice how there's an intersection there. So if you need a refresher to intersect, to find the intersection point, we go to second, trace, 5. They're going to ask you for your first curve, second curve. You're just going to press enter, enter. And since there's only one intersection, there's no need to guess. I'm just going to press enter again. So it looks like theta is roughly 2.017 if rounded correctly. Let me double check real quick for B. Okay, cool. Okay, so now we want to find out what the y coordinate is at this point. So now that we know what theta is at this point, we could just take our theta and plug it in here. Now, I don't know if it's going to come out a different answer. Actually, let me write this out first. I know that y will equal r sine theta, or in this case, 3 theta plus sine theta, which is r, times sine theta. Now, since 2.017 is the final answer for theta, I want to make sure that I don't use the rounded answer. You know what? I'm going to try it. I'm going to go ahead and go to the home screen. And I'm going to go ahead and press 3 times 2.017 plus the sine of 2.017, close it, twice, times the sine of 2.017. I'm getting 6.272. Let's see if rounding it causes it to change. No, it didn't. Okay, so it looks good. A lot of plug and chug. Your calculator's doing all the work. You just have to tell it what to do. Okay, and then here's part C. Particle traveling along a polar curve, r, so that's position t, x of t, y of t, such that d theta dt is equal to 2. Okay, find dy dt at that instant. And interpret the meaning. Okay. Okay, find dy dt. dy dt, so d theta dt. To be honest, I don't know about this one. Let me take a look. dy dt. Ooh, gross. Okay, I mean, I'll be honest with you guys. I didn't think of this at first, but I can't make sense of what they're doing. So from here, we have our y equation, which is in terms of theta. So we could actually find dy d theta, but notice how they're asking for dy dt. So this is kind of like the chain rule here. So dy dt is the same thing as dy d theta times d theta dt. Okay, so dy d theta times d theta dt at this value. And then they do tell you that d theta, hang on, d theta dt is equal to 2, so they kind of give you the value there without having to guess. So 2 times dy d theta, evaluate it at 2 pi over 3. Okay, so here's what you could do to expedite this, all right? You could make your y1 as 3 theta, or in this case, 3x plus sine x times sine x. And then what you could do there is you could press math 8. Actually, you should do 2. And then you should do math 8. So then it will be d over dx of alpha trace y1 at 2 pi over 3. That's probably the fastest way to get your answer there. That doesn't pop up too often. In case you're wondering, like, well, we have to remember this part right here. Again, doesn't happen too often there. All right. But I guess there's a little more to it. So it came out something negative, negative 2.819. So dy dt came out negative. Okay, so remember, you also have to, wait, what did they ask for? Interpret? Okay, so dy dt is negative, which implies that y is decreasing. And there you have it. Cool? Okay.